Excellent. Thank you, everyone. Good morning, good afternoon, wherever you are. So my name is Indrasis Mondal. We just talked about it. I'm here with my team member, Adam. And we're going to talk a little bit about our practical applications of NLP. We just heard the conversation before from David about different NLP models, no code, low code, the implementation of NLP. So what we're going to do today is we're going to talk about how in my team, we're using ensemble NLP model to actually drive actionable insight from our feedback that we receive from in product. A little bit of agenda for today. We only have 30 minutes, so I'm trying to keep it simple, and then hopefully we'll have some time at the end for Q&A. So we'll talk about the introduction, a little bit about us, which we kind of already did. I'm going to talk a little bit about the team, what we do. Then we'll talk about the problem statement. What is the problem and why we're trying to solve? And then we're going to talk about the solution that we're planning to build or hoping to build. Adam is going to talk about exactly how we implemented the solution, the learning and the next steps from that. And then hopefully we can end with some Q&A. I'm not going to spend some time at all. We already talked about it, so I'm going to skip this. A little bit about the data science team in DocuSign, especially the product data science. We just have one ultimate purpose. Our purpose is to enable a culture of data-driven product development in DocuSign. In order for us to do that, there are 6 areas we focus on. The first and foremost is around product instrumentation and telemetry. So we build capabilities in terms of making sure we're able to collect millions and billions of events around our product and feature usage, so that we are able to get the right data in a consistent quality form so that we can do our downstream analysis. We as a team also build certified product and feature usage data source as a reference data source. You can think about it as a data mart, ODS, that the rest of the organization can use for driving any sort of product intelligence from the data. We focus on product analytics, product metrics, KPI. We build data science and ML models, and products in order for us to drive usage, adoption, experience, as well as other product-facing product. We also own the experimentation and campaign practice and capabilities. And finally, we also have a data engineering function that sort of supports all the things that I talked about. Quickly on the problem statement. So if you think about as a SaaS company, we collect a lot of in-product feedback from our customers. So when you probably have seen it, and you're going to do that as soon as you hang out your Zoom today. It's going to tell you exactly how was your experience, and do you have any feedback? So any SaaS company, and DocuSign is no exception, we collect quite a lot of different feedback at the different part of the experience. Either it's for our NPS or in product satisfaction. In each of those comes with 2 things. One, it comes with a numerical score. Either it asks you to give a score between 1 to 10 when it comes to NPS, or it will ask you to give a score between 1 to 5 or 1 to 7 if it is something like a product satisfaction survey, which is more like your Amazon.com review, if you will. The scores are really important because that's immediately gives us an indication of how we're doing overall. But there are more important part of that is the actual feedback that you get from our customer. One of the problem that anytime you have a system like this, there are literally thousands and tens of thousands of comments that are coming in. If you are a PM, for you to go, browse through all these comments and trying to understand what exactly are people complaining about your feature that you might need to pay attention to improve, it's almost like trying to find a needle in a haystack. So what we are trying to build, if you can imagine a system where you take all these comments, put it through a box, and what it does is it takes those comments, trying to find out the relevance of those comments. Is it along with its sentiments, is it good or bad, or indifferent? Which product are people talking about? And once you are able to categorize that, what features of a particular product they're talking about, and then what exactly about the features they're either giving you compliment, or you're asking us that we should change something in order for us to make the product better. And this is where we used ensemble NLP, and Adam is going to talk about after this, where the system we're building, this takes all this product, it's do the initial classification of whether it's relevance or not, take that, split that into groups of product, then split that into features and clusters them based on what actually the type of complaint people are doing. And if you're a product manager at that time, all you are caring about is getting to the right information at the right time through the product that we're building in-house, so that exactly what specific things you need to pay attention to in your feature in order to improve it. So with that, Adam, I'll hand over to you if you want to sort of talk through the solution.
Yeah, absolutely. Thanks, Andy. So I'll start with the data set. So we grabbed about 10,000, little more than 10,000 comments from users. This was from September 21. So essentially, we just grabbed all of the user comments from roughly a month. And these are our web users. And we're not surprised to see that the majority of these comments we would label as non-relevant. Sort of the modal comment that we get is something like, I don't like this, or I'm too old to learn this technology, or something like that. But roughly 1 in 10 provides something relevant. And by relevant, we mean referring to something specific within the feature, within the product or the features, right? So the first step is taking these comments and then labeling them as relevant or non-relevant, because that's going to help us train the first layer, which is going to be a binary classifier based on relevance. Once we have our relevant comments, then we need to do labeling at the topic level. Like Indy mentioned, this is an ensemble approach. The first layer is going to classify based on relevance or not. The second layer is going to organize relevant comments by topic. So this part gets a little more complicated because we have to decide what those topics are, right? Relevant, non-relevant is relatively straightforward, but what are these topics going to be? So here, what we needed to do was work with our end users to develop what those topics were going to be. We came up with 4 distinct topics, and then we go through and hand label those as well. And so we had at least 300 observations in each one of those topics, just to give you a sense for the size of the data set, and a little bit more about what these look like. As you might imagine, them being comments in response to a survey. They're relatively short, less than 300 characters, more or less. And how this relates to the general population, just in terms of response rate. Most people do not respond to the survey. So we get about 14% response rate. And that's just to the survey, right? And the survey is a quantitative metric, right? So of those that respond to the survey, about 15% actually leave comments. So all told, we're looking at about 2% of all users who leave some kind of a comment. So that's just to give a sense for the size of this data set and also who's represented in this data set. All right, if you want to go to the next slide. Okay, so how are we going to go about building the classification here? So I'm glad that David's talk preceded ours, because he talked a lot about transfer learning and a pre-trained model, and that's essentially the approach we did here. So what we did is we used the BERT model that was built by Google about 5 years ago, built on a very large corpus, and that allows us to take our data set, which I just described, labeled data set, and use that to fine-tune BERT. And so BERT provides a number of advantages. Like I mentioned, it's built on a tremendously large data set, much larger than we would be able to build in-house, given the amount of data that we have and the amount of GPUs we would need in order to do that. It also has shown in repeated examples to provide really impressive results on various classification techniques. So you can use BERT for a variety of things, but it's very strong in terms of classification results. So then the question ends up being, if we're going to use BERT, do we believe that there's going to be a fair amount of overlap between the types of comments or observations that we're trying to classify and what is in the BERT, what built the BERT model, essentially. And there, BERT is built on a large section of the Wikipedia corpus that's online. And so there's going to be a fair amount of overlap, both in terms of language and types of comments. that's going to help us be able to label future observations that are outside of our data set. So that was essentially our thinking. And of course, BERT being open source as opposed to something like GPT-3, that also provides us an advantage, because then we can use it and build from it. So that was kind of our thinking around using the BERT approach, as opposed to, for example, building a model from scratch, which is something we'll talk about towards the end of that presentation. Next slide. All right, so there are essentially 4 types of hyperparameters to consider when we're thinking about using BERT. BERT is not an individual model. There are several versions of BERT based on size, language, casing. We used English. The overall majority of our comments are left in English. We use the uncased model, and we used, I think, the small model. There are several sizes of BERT, and the larger the model, the longer the training time. So first type of hyperparameter is which model type. Second is which optimizer you use. BERT is, as far as I know, always optimized using a weighted atom approach. So then the hyperparameter you're thinking about there is the learning rate. The BERT authors recommended learning rate of between 2 times 10 to the -5th and 5 times 10 to the -5th as learning rates. Those 3 learning rates essentially. So we went with 3 times 10 to the -5th for the binary and 5 times 10 to the -5th for the multi-class classifier. We did this after trying the variety of different learning rates suggested by the authors and finding that these worked the best for us. And another hyperparameter within the optimizer is how many epochs you're using to train. And here we did 5 for a binary and 10 for a multi-class. This is again a question of how long the tuning time is going to take. And then the second 2 hyperparameters, I should say the third and fourth hyperparameters, are which loss function and which accuracy metric. For the binary classifier, we use the binary cross entropy and binary accuracy for those 2. And then for multi-class, we use categorical cross entropy and categorical accuracy. Next slide. All right, so some results. We were pleasantly surprised and happy with these results. We got a binary accuracy of 88, almost 88.5%, and the multi-class classifier just under 80%. And then sort of within each topic, the F1 score for each of those topics were between 75 and 84%. So this provided us with a fair amount of signal. And keep in mind that as Indy mentioned at the top, the end goal is to add value to our PMs who are using this data, to allow them to drill down to individual comments that are talking about specific topics that they're interested in, right? So we don't need 100% accuracy. We're obviously happier with the higher level of accuracy, but what this allows us to do is then surface those comments that we believe has targeted exactly what our PMs are going to be interested in. Now let's see. I see we have a question here. Did you train BERT with your data? Yes. So essentially what we did is we started with BERT and then used the fine tuning based on the data that we brought in, right? So the data set that I mentioned a few slides earlier, that was the fine tuning, right? So once we had the labeled data set, BERT requires you to have some kind of labeled data set, that fine tuned the BERT. So we basically had the generalized BERT, which we were able to specify for our purposes. And so that we created 2 model objects, right? A binary classifier and a multi-class classifier, and both of those were fine-tuned using our specific data. Okay, yeah, next slide. Okay, so just to kind of run through sort of visually what this looks like. As Indy mentioned, we're dealing with an ensemble which has 2 different layers: the binary classifier and the multi-class classifier. So what the binary classifier does is assigns a relevance score or probability between 0 and 1, right? And then we can use a threshold. Initially, we use 0.5 to determine whether a comment was relevant or not. And so, you could think about these comments as coming in. You can see the middle 2 refer to something specific within the product and the experience. And so they are calculated at a high level of relevance, right? And then next slide. And then those comments are then assigned a topic level probability, right? So this is an important distinction here. The multi-class classifier does not sort each comment into a specific topic bucket. You can think about it as a series of binary classifiers. It assigns a probability for each topic, meaning that if there is a topic that somehow is labeled relevant but does not fit any of our topics, it's possible that it would have a low probability for all available topics. Inversely, if it touched on multiple topics, it could have a high probability for multiple topics. So this is important for a couple of reasons. First of all, we're not trying to determine exactly which bucket to put each comment in. And as I'll show in just a second, when we think about the end user's use of this specific data, what they want to do is they want to be able to surface comments related to the topic of interest. So when they're filtering by topic, it can be the case that a specific comment shows up in multiple filtering scenarios. Okay, so that's part of the reason for this approach. Also, this is the way that this multi-class classifier works. So here I have this example of this specific comment having a high probability in one topic and in none of the others, but it's important to emphasize that it could possibly have a high probability in multiple topics or none, just given how the classifier works. All right, so next slide. Let's look at what this looks like in current use. Okay, so I built a wrapper script that calls to these stored model objects. Like I said, we have the model objects of the binary classifier and the multi-class classifier. And so we get these new observations and we do a batch process of calculating these probabilities, both relevance and topics for these new predictions, right? And then we dump those into a table that is the back end of this dashboard that you're seeing here. And then end users, and as Indy mentioned, the end users are a subset of the PMs at DocuSign. They then have access to a dashboard where they can filter down based on relevance, topic, and sentiment. So here you can see a little bit about what this dashboard looks like, right? They're looking at the timestamp of the comment itself, and then they can, and the score also, because this is an NPS. And then they're able to filter down by topic and then by relevance. And what this allows them to do, as opposed to dealing with tens of thousands of comments every month, and kind of dealing with like Indy mentioned, a needle in the haystack, what we're getting them to is just a pile of needles, meaning all the things that they're looking for, right? So that they can look through this qualitative data, but drill down using quantitative methods to get at just the comments that are relevant to their area of interest. Next slide. All right, so let's talk about some learnings and next steps. As I mentioned at the top about the data set, this is a data set of about 10,000 observations that required hand labeling. That process we would really like to be able to automate in the future, or at least partially automate. It takes a long time to hand label observations, especially at the multi-class level, even though there are fewer of them. So if there's some way that we can automate that process, that's really going to help with future topics. Topics will change, interests of PMs are going to change. And so that will make this process a lot more scalable if there are ways for us to automate or even partially automate the process of labeling the data set, which will allow us to create new model objects based on fine-tuning a different version of BERT, or say the same version of BERT, but fine-tuned with different data. Something else we're going to be looking at doing is subdividing topics into what I'm thinking of as topic trees. So, like I mentioned, we have 4 topics, but as we get more data and more comments are labeled into each of these buckets, what we can then do is subdivide these buckets into more fine-grained topics, and that'll provide more value and hopefully allow for more PMs to get value add from this particular product. And then something I mentioned at the top is, why BERT? There has been some research, especially on the multi-class side of things, that we might be able to just use our own LSTM as opposed to a transfer learning approach. Basically, build an LSTM for the multi-class in order to do the multi-class layer. That's possible. Our team, other data scientists on our team, have a fair amount of experience with LSTM, so that's something that we're also looking at. If there's a way that we can work on the multi-class layer using another approach like an LSTM.